Good evening. This is Bob Rapp, and we're having a little conversation about AI, machine learning. And as we think about artificial intelligence, we think about machine learning, we think about things like structured and unstructured, proctored and not proctored. Do we need feedback and regression and RNN and CNN and all those other concepts? Let me take you through an example that I think is pretty interesting. So let's start with baking. As many of you may know from Bob's Bread blog, I make version 42 of bread. It's in its 84th week, and everything is done in my kitchen here with my bread machines. I've got 10 of them, but these are the two most popular. They're both actually Hamilton Beach. This one, although, looks like the Food Network. So what we know is that in bread, which is going to represent the data, we have some ingredients. And sometimes when I talk to customers, they say, well, I know that the ingredients are liquids and I think there's some sort of powders, and so we're going to make bread, but we're going to give you two different data sets. We're going to give you data set from bread 42. Then we're going to give you some other powders, other data. So we're going to give you some Coffee Mate, some Mexican hot pepper, some sugar, vinegar, and of course some sesame oil. And what we're going to find is that garbage in is garbage out. And so we're going to take a look at what that means as we go forward. So a reminder, for Bob's bread, we need 300 grams of water, 32 grams of organic olive oil, and 74 grams of honey. So we've got our honey, our olive oil, and our water, 300 grams, 74 grams, and 32 grams. And if we think about these as data, this is our core customer data. Now we're going to put in some other values. And again, when we think about features versus targets versus labels, we'll talk more about that later, but we're going to add some more data to the mix. So I've got all the ingredients in. I've got in my flour, my salt, my yeast, my crushed flax, my sesame seeds, my wheat gluten, vital wheat gluten, my pumpkin seeds, my sunflower seeds, my 7-grain cereal back there, and finally my unbleached white flour. So now we're going to put this in the bread machine, and when I'm trying to explain to customers the difference between supervised and unsupervised with feedback, with regression, and all that stuff, I start by saying every bread machine starts with a license, no matter who it is. This is Hamilton Beach. Starts with a license from a company that is called Zorushi in Japan. We're going to put this on, by the way, this particular algorithm is medium, regular bread, and 1.5 pounds. Let me go ahead and change the loaf size. There we go. We're going to say start, and you're going to start to hear and see the bread machine working. Now, one thing that you could do is you can leave a bread machine working by itself, and if you do that and you don't actually come back and give it a feedback, in this case, if you don't get the stuff off the sides, you're going to get a really chunky loaf. So we're going to let that go for a little bit, about 20 minutes, and go make our terrifying bad data bread. Here comes the bad data bread. Core ingredients that I need, you see the yeast, I've got water, sugar, and oil, but now we're going to put in some terrifying ingredients which represent some bad data. First, we're going to put in some sesame oil, probably not a best practice. Then we're going to put in some Mexican lemon pepper. We're going to put in some creamer. Oh, that's terrifying. This is not going to be good. And then, as lots of people say, well, hey, isn't liquid? Remember, garbage in, garbage out. Bad data, bad result. So we're going to put in some vinegar. Ugh. And then finally, we're going to top it off with a little bit of white sugar. And then, just to make it more fun, we're going to put in the wrong proportions of flour. So hold on a second for that. Well, as you can probably see, normally when you see this sort of ingredient, it's a little bit terrifying. We're going to, though, use the same algorithm, the same bread machine. It's the Hamilton Beach algorithm. We're going to put it in. We're going to put it on medium, and we're going to start this thing mixing here. And you'll see that we're actually going to make something. It probably won't be bread, but it'll be something. So there they go. In about 3 hours, we'll come back and see what they look like. I fear it won't be pretty. So key things to remember. What's your recipe? Do you have the right ingredients? Do you have the right person to make the thing? Do you have a baker? Do you understand how to change the recipe so that you end up with delicious bread? And most importantly, do you understand what the right algorithm is? Because if we were going to make this very same bread in the coffee machine, that would be a problem. There's our coffee machine. That, by the way, would be great, but if we put flour in here or sugar in here, we would not end up with delicious espressos and cappuccino. Now, there's lots more to talk about, and we can talk about all the ways we do machine learning at AWS, which algorithm is better for what problem. But what I find most of the problems with customers, doesn't matter their machine learning platform or their AI platform is, do they have the right problem defined? Is it binary? Is it multivariable? Have they thought about the right algorithms to use? Have they run some tests? Do they have test data, sample data, dev data, sectioned off? Usually, by the way, the training data is going to be about 80%, dev and test about 10 and 10 each, but it really depends. And do they know what the outcome is supposed to be? Because a lot of times if you don't do the question, what does bread look like, you get to the problem that you think you're doing artificial intelligence and you're kind of just doing artificial stupidity or bad mistakes or bad choices. So there's lots of things to do. There's some best practices we can use at AWS. There's some templates we can use. Let's actually go in the interface right now, go into SageMaker and, start a project. Let's go with some known truths and end up with some good results at the end. All right, thanks a bunch. This is Bob Rapp from Bob Rapp's Bread Blog. Take care, you guys. Bye-bye. Okay, we're back to the notion of, are we going to give feedback to the model? Are we going to do any sort of guidance, or are we going to train the model? And by the way, training can come from a human, it can come from history, it can come from data, but I'm trying to make a specific example about bread. So hold on. So you'll see in here, if we didn't knock down that stuff from the sides, we'd get a pretty ugly loaf, and I'm expecting to get an ugly loaf on the other side, in addition to the fact that the ingredients are wrong. This one, oh goodness, I don't know what that's going to be, but that's probably not going to be bread. That looks terrifying. So the key to making bread machines work is making sure that about 5 to 20 minutes into the process, depending on the type of bread you're making, that you check and you help the algorithm, because the algorithm knows how to make bread. What it can't deal with is external variables, like lots of AI. By the way, this is a very basic kind of AI machine learning, this protocol or this algorithm from Zerushi. But now you see that we're not going to get unmixed flour in the bread machine. Get here, because that doesn't really look like bread. It's going to be, I apologize in advance to all of my friends on the bread blog. Oh, goodness. One of the things I do with bread machines is test machine vision. So if you think about the notion of the color of bread machine when it comes out, this of course is also where I have all my spare electronics. But this is the place that I can actually make comparisons between the very same machine. So I have the same version of the same, so sort of same BIOS version of the Breadman Ultimate here. And it's interesting, we're doing side-by-side tests. And when you're talking about algorithms, it's always interesting to see exactly the same data with different algorithms equals quite different results.